6-3. Everybody should have 6-3. There's 2 pages for 6-3. We want the one that looks like this, and here it is. Oops, 6 dash. Oh, that's not the right one. We want 6-3. Make sure you're getting 6-3, not 6. Here it is. All right, it looks like this. There's 2 pages that go with 6-3. One is just notes and the try these problems. These charts and graphs take up a lot of space, so I had to use 2 pieces of paper for this one. All right, today's lesson, just hold tight, stay with me. It looks a little bit wordy to begin with, but when we start doing the practice, you're going to say, oh, all right, that's all it is to it. We're going to study mathematical relationships, and we're going to be studying 2 of them. 2 of them. All right, here's some reminders from yesterday. A relation is a relationship. Doesn't that sound weird? Sounds redundant. Okay, so when they talk about a relation, it's a relationship between sets of values, because this is math class. So outside of math class, a relationship might mean something else. Your relationship with your grandparents or your parents or your girlfriend or your boyfriend or whatever. In math class, it's between sets of numbers. All right, so for us in math, because this is a math class, the relationship is going to be between x and y values of an ordered pair. That's why 6-1, which y'all said, oh, this is so easy. We had to go back and do coordinate grids. Nathaniel, you need to stand up, something? Wake up, baby. All right, get your pencil in your hand, move it on the paper, maybe that'll make you wake it up. All right, ordered pair. Okay, that's what a relationship is for us in math class. What's happening to the x and the y? What's the relationship between the x value and the y value? And we got to try to determine what is the relationship. All right, the set of all of your x values, we can call them the input. We input them into the math magic machine. They are sometimes called the domain or the independent variable. And yesterday we were watching the video, and that word came up. It said that all the x values could be called the domain, and all of the y values are the range or the dependent variables. Okay. Okay, here's the 2 types of mathematical relationships right here. Here's number 1. They're called additive relationships, and it kind of the words say exactly what it is. It's a relationship where we're adding something to x to get y. Additive, it means addition. And then the second one is called, I love this word, multiplicative. That just means multiplication. It's just a fancy way to say multiplication. So the word itself tells us what kind of relationship this is going to be. We're going to be multiplying something by x in order to get y. All right, so the title itself tells you what's happening. Additive relationship is going to involve addition or subtraction, because the opposite of addition is subtraction. And multiplicative, I love that one, multiplicative, that means multiplication, but it could also mean division, because it's the inverse of multiplication. All right, let's look at just additive relation first. Let's just look at additive. All right, additive involves only addition or subtraction. All right, even though they just call it additive relationship, they don't call it a subtractive relationship, because by this point you're supposed to understand, let me just do an example, 1 plus -3, okay, all right, is the same thing as 1 minus 3. All right, so every addition problem can be written as a subtraction problem, and we get the same answer. We get the same answer, and every subtraction problem can be changed into an addition problem by adding the opposite. Okay, so adding and subtraction go together, but they just call it an additive relationship. Okay, because they're both the same. Adding -3 and just minusing 3 is the same thing. All right, the equation looks like this. Y equals x plus b. All right, now I don't know why they picked b. They just picked b. Maybe b for the back number, the number in the back. I don't know. All right. Now there's a rule though that b cannot equal 0 because you have to be adding something. And if you add 0, you're not really adding anything. So b can be a negative number, a fraction, a decimal, a positive number, but it cannot be 0. Okay, that's the formula. We're going to need this one. This is the rule. That's for additive. And see, we're adding. That's why it's called an additive relationship. The same quantity is being added to every x value. Okay, you got to be fair. Every one of these numbers in the table have to be treated the same way. Have to be fair. Okay, so now let's look at an additive relationship. We can see the rule. We're adding 2. All right, we're not multiplying by anything, are we? Nope, it's just adding 2. There's no number in front of x that we're having to multiply. It's just additive. So let's go ahead and add. All right, I don't even think you need a calculator for this one. I'm going to plug in 0 right here. 0 plus 2 is 2. When I plug in 1, out comes 3. When I plug in 2, out comes 4. When I plug in 3, out comes 5. A lot of times in these additive relationships, you're going to see a pattern. If your x values are consecutive in order, you're going to see a pattern come out. 2, 3, 4, 5. We put in 0, 1, 2, 3, and got out 2, 3, 4, 5. Okay. Any question about how we plugged in and got there? All right, look at what we have. We have a nice table. If we put parentheses and a comma in the middle, we have 4 ordered pairs. 4 ordered pairs. So let's take each one of these ordered pairs and graph them over here on the coordinate grid or graph and see what happens. All right, so this is why we had to do 6-1. The baby starts here on a blanket in the middle of the floor, and then we run to the refrigerator to get a bottle of milk. And when we come back, that baby has moved and stood up next to the coffee table, and there it is. It's not in the middle of the floor anymore. All right, so we just graph that one. All right, we leave the baby back in the middle of the floor, and this time we go to the bedroom to get its pacifier, and when we come back, the baby has crawled over one and stood up here on top of the sofa, bouncing on the sofa. Okay? We put the baby back in the middle of the floor, and this time we have to run to the bathroom, and when we come back, the baby has crawled over 2 and is standing up on the coffee table. TV. Okay, TV, whatever. All right. We put the baby back in the middle, and we go to get the mail, and when we come back, the baby has crawled over to 3 and is hanging from the light fixture.
What?
Okay. What does it look like we have here?
Oh, line.
Yes. All right. Do you see how every one of them fall into a line? We could take a straight edge, and I'm just going to do it. I'm going to insert, and I can do a handy-dandy. Oops.
Calculator.
And I can move it over. All right, do you see how every one of those points, let me adjust it just a little bit more. Every one of those points are on that line. That means we have done it correctly. If we had graphed one of these and it ended up being, let's say we made a mistake and we said the baby went over 3 but fell down, do you see how that point is not on the bar, on the line? We would have known this is wrong. We did something wrong. All of them are going to fall on a straight line. When you get a ruler or a straight edge, you're going to connect them, and every one of them are going to be on that line. That's an additive relationship right there. Okay? All right. Let's look at multiplicative and see what the difference is. All right. So now a multiplicative relationship involves only multiplication or division. It could be division because division is the opposite of multiplication. I'll show you. All right, if we said y equals 1/2 times x, that's the same thing as saying x divided by 2. So see, one's multiplying and one's division, but they mean the exact same thing. Okay? All right, here's the equation. The equation is y equals mx. M, I don't know why they picked the letter M. Maybe M for multiplication. because that's what we're actually doing. M for multiplication. Nathaniel, do you need to go get water or something? You got to wake up. Go stand up, move around, something. All right, y cannot equal 0 because what happens when we multiply something by nothing, it becomes nothing. So you can't have 0 because you're not really multiplying. Okay? All right, the same quantity is being multiplied. Oops, I got to spell it right. Multiplied or divided, they mean the same, by every x value. Okay. All right, let's look at an example. So here's the additive one, remember? There's the additive, and the rule, we were adding something. We weren't multiplying by anything. We were just adding. It gave us 4 ordered pairs. We plotted them, and we said, oh, we got a line. It has to form a line. If we plotted one and it was over here, we're like, no, we did something wrong because it's not on the line. Okay? All right, let's see what happens with multiplicative. All right, so here's our rule. 1/2, we're multiplying it by a half, so we can really say we're dividing by 2. So if we cut -2 in half, we'd have -1. If we cut 0 in half, it's just 0. If we times 1/2 by 2, that's 1, because we're basically dividing by 2. And if we cut 4 in half, that would be 2. All right, now we have 4 ordered pairs. Look at these relationships we have. We have 4 relationships here. I'm going to take those and I'm going to put the point over here on the graph. And Jamal, what do you think? Are we going to get a line out of this one? Let's see what happens. Okay. All right. Baby's back in the middle of the floor. We go to put the laundry in the dryer. And when we come back, that baby has crawled over to -2 and fallen down a step. Put a baby gate up. Anytime you got babies in the house, you put a baby gate up anywhere there's steps, and that's where the baby is. All right, we put the baby back in the middle of the floor, and when we come back from getting a package off the front porch, that baby fell asleep, and it's still there. Miraculously, it did not move. We're not having to hunt for the baby. All right, then the baby wakes up and the baby crawls over to 2 and pulls up by the coffee table. Doesn't it look like we're getting a straight line again? Okay, all right, let's do the last one. This time the baby went on a journey all the way over to 4 and is standing up on the side table next to the sofa. All right, so it looks like we have a line. All right, you would be using a straight edge. We're not going to get the rulers out today. All right, so I'm going to use my handy dandy line and just make a little bit of adjustment if I need to get them so it looks like it goes through. And yep. Okay, now there you go. All right, so if we had made a mistake and graphed one of these wrong and said, and we had a dot over here, we would have like, whoa, hold on a minute. Something's wrong, because they have to be on the line. Okay, all of them have to be on the line. All right, let's compare, because I see that they look very similar. So let's look at the additive one here, and let's look at the multiplicative one here. All right, so they're both straight lines. Do you notice that this one goes right through the center, the middle? All right, look. Multiplicative and middle. If it's multiplicative, the line is always going to go through the origin, the middle, the origin. That's multiplicative. If it's additive, it's never going to go through the middle. It's never going to go through the middle. All right, so that's one way you can tell which one is which. All right, let's try them. Let's just jump in here. We got to decide, is it an additive relationship or is it multiplicative? And in order to tell, we have to find the rule. We have to write the rule. All right, and remember the rule is going to be in this format. Y equals mx, and we're going to figure out what the number is for m, or it's going to be y equals x plus b. This is additive, this is multiplicative, and we have to figure out what are we adding to everything. All right, so let's look. Pick any numbers on here. I like to go to the positive ones first because I think they're easier to work with. What could they be doing to 1 to get to 5? There's a couple of things. Nathaniel, what's one thing they could be doing? All right, it looks like we could be adding by 4, or they could have been multiplying by 5. All right, but let's look at the next number, and that will determine which one is right. Well, definitely times 5 isn't going to work, because 5 times 3 would be 15. So we're taking that off the table. So it looks like plus 4. All right, let's check it. -1 plus 4. Yep, that would give us 3. -3 plus 4, and you could check it with your calculator. Yep. So the rule is going to be y equals x plus 4. And this is an additive relationship because we're adding. We're not multiplying by anything. And notice that Nathaniel had to find a rule that worked for every x value to get the y out. All right, let's look at the second one. All right, let's just start at the beginning. What could they do to -4 to get to 16? There's a couple of things that they could be doing. What's something that you think could be happening here? We started with -4 and we get to 16. Antoine, what are you thinking? All right, she's thinking multiply by -4. All right, or you could have been saying we could be adding something, but when we look at this level, you can't be adding anything because it's 0, 0. It's going to go through the middle. Anytime you've got 0, 0, you know it's going to go through the middle. So this is going to be a multiplicative relationship. And let's just double check. Yep. If we multiply by -4, yep. We'd get 0, yep. We'd get -8. So we're going to say y equals -4 times x. There's the rule. Okay, let's look at the next one. All right, what could they do to 0 to get -3? Now, we know that this can't be multiplying, all right, because in order to get from a 0 to another number, it has to be adding or subtracting. So to me, it looks like they are, oops, I don't want to put parentheses because that looks like, all right, it looks like they're minusing 3. All right, let's check it. 2 minus 3, yep. 4 minus 3, yes. 6 minus 3, yes. So this is going to, it's not multiplying, so this means additive. Even though we're looking at it as subtracting something, that still means additive because we could write it like this, or we could write it like this. Both of those mean the same thing. Y plus x plus y equals x plus -3, or y equals x minus 3. All right, so that's an additive relationship. We're not multiplying x by anything. We're just adding or subtracting. All right, now we got to look at the tables and we have to find the rule. And some things are missing. We got to find the missing pieces and we have to figure out what the rule is. All right, so go to some numbers that you can see. What could they do to 7 to get to 35? What could possibly, Zaya, be done? All right, it looks like we're timesing by 5, so let's test it with this one. Yes. All right, -5 times 5 would be 25. So that looks like the rule is going to be y equals 5 times x. That's going to be a multiplication. Multiplicative relationship. Now let's finish the table. 3 times 5 would be 15. And then what number times 5 would give you 45? That would be 9. Okay. All right, let's go to this one. All right, what could be happening to get from 3 to 15 or from 10 to 22? What do you think the rule might be? It's got to work for all the numbers, and they gave us 2 of them already filled in. What do you think, Anastasia? All right, it looks like we're adding 12. This is the easiest one for me to start with, so I'm just going to double check it. Yep. All right, so we add 12 here, so that's going to give us 34. And what number plus 12 would give me 27? We're going to fill that one in with a 15. All right, so the rule is y equals x plus 12. So that's an additive relationship. So when we go to graph it, we're thinking, oh, it's going to be a straight line, and this one is not going to go through the middle because it's not multiplication. All right, next one. What could you do to 6 to get to 2 and 18 to get to 6? What would be happening there? How what? All right, no, because that would be 18. Do the inverse. 6 times 3 would be 18. We get 2. So do the inverse of what you just said. What would you do to 6 to get to 2? Because we got to go in this direction, from x to y. Divided by 3. Okay, 6 divided by 3 is 2. 18 divided by 3 is 6. So let's finish the chart. 9 divided by 3 would be 3. 12 or 21 divided by 3 is going to be 7. So let's write the rule. We can write it 2 different ways. I'm going to say y equals x divided by 3. And notice we're doing it the mature way as a fraction, and we're not saying x dot dot 3 with a little old division sign. Or somebody might have said, well, I look at it as 1/3 times x. Both of those are the exact same thing. All right, let's put it all together. All right, we have to find, they give us the rule. They give us the rule. We got to fill in the table, and then we're going to take each one of these and we're going to graph it, and we should get a straight line. If it's an additive one, is it going to go through the middle? Okay, so we already get our mindset, a straight line that does not go through the middle. This is a multiplication. Even though some people don't see it, it's a -1 times x. There's an understood invisible 1 right there. So this is a multiplication, which means it should be a straight line and go through the middle. Multiplication goes through the middle. Let's check and see if it happens. All right, plug in your numbers, use your calculator as needed. All right, plot your points. All right, when we're getting into this unit, I always have straight edges over here for you to borrow in class and put them back. I would suggest, most people have tons of these laying around. I never throw mine away. When I use a gift card, I put a big X on it so I know it's no money on there. And these make excellent straight edges because they fit in your notebook really nicely, and they're hard plastic. And this is about the only line. You don't need a really big one. But I also have protractors over here too, because when we really get into this, it has to be a straight line, so we'll be using rulers. All right, so let me put my line on here. My program allows me to draw a line with a ruler. Okay, there we are. I got a straight line. All of my dots are on the line, and it did not go through the middle because this is additive. This is an additive relationship. Okay, all right, now over here, this is a multiplicative, so I'm anticipating once I find my 4 points, they're going to be on a line, and one of them is going to go through the middle. It should go through the middle. Okay, so let me go ahead and see if my prediction holds out. All right, -1 times -3 is a +4. Use your calculator if you don't know your integer rules too well. -1 times -1 is a +1. -1 times 2 is a -2, and then 4. All right, so I'm going to put my 4 points. I think it's very satisfying when I put those 4 points and I can start to see that they're falling in a line, and then I connect them, and you know you have the answer because it's a straight line and all of them are on it. I think it's very satisfying. -3 up 4. -1 up 1. 2, 2, 4, 4. All right, I put my points on and they appear to be in a straight line. So let me just double check and draw my, when you put a ruler next to those dots and you get that straight line, you can really tell. All right, so it looks like, oh, let me adjust it. I was saying it looks like one of mine is not on there. Okay, so I have an issue. Do you see how, what is the problem here? Something is wrong. Something is off with mine because this one right here is not. So somewhere, let me double check my math. Oh, right here. -3 times -1 is not 4. So see, that does, something was off here. So let me go back. I made a mistake, which happens. All right, -3 times -1 is a +3. So let me change. Can I get rid of that line? Hold on, let me see. Can't get to the line. I want to get rid of the line. Won't let me get rid of it. All right, let me just erase. And let me do it correctly. -3, 3. -1, 2, 4. All right, this time, let me put my ruler on there this time and see if they're all on the line. And it looks like I got it right this time. There you go. They're all on the line. Do you see how it is going through the middle? It's multiplicative. It should go through the middle. This one is multiplicative. Multiplicative. And it's going to go through the middle. Right there. Through the middle. All right, guys, for your homework and Core Plus time, use your Core Plus time wisely because tomorrow might be a snow day and you want to get out and get some stuff done. Shh, still talking, thank you. All right, let me go ahead and stop our video for those of you at home. All right, 6-3.